Thank you for joining us. I'm glad to have you. Today, I want us to look at motion under gravity, otherwise known as gravitational acceleration. Now, if an object is thrown into space or is dropped from a certain height, the motion of that object is affected by gravity. For example, if an object is thrown vertically upwards, and of course, because it is the motion is against gravity, because it is against gravity, it experiences what we call negative acceleration. It experiences negative acceleration. Therefore, the acceleration is minus g. Now, on the other hand, if it is dropped from a height, and of course, you know, gravitational force is just the drag of the earth, or how the earth drags every other object towards its center. So, if I drop this from a particular height, then because its motion is in the same direction with the gravitational drag, then when it experiences positive acceleration. Positive acceleration. So, in other words, acceleration due to gravity is G, positive. That is why when I say that when an object is thrown up, the motion is under it's against gravity. It has negative sign. If it is released from a height, it is in line with gravitational force. Because of that, we have G to be positive. Now, I want us to look at the equations of motion under gravity. Now, it can be gotten from the equations of motion. Remember, from our previous class, we were able to generate the equations of motion that says the first one, V is equal to U plus AT. Now the second one gave us S is equal to UT plus half AT squared. The other one gave us V squared is equal to U squared plus 2AS. Now these equations, we are going to consider this equation based on this. Now we now have case 1. Case 1 is if the object is projected or thrown upwards. If the object is thrown upwards, if it is thrown upwards, then this acceleration here will now change to negative acceleration. But if it is thrown downwards, or if it's released to move freely, A changes to positive G. So because of that, this equation will now represent this equation here when the object is thrown vertically upwards. So when it is thrown vertically upwards, we have V is equal to U minus GT. That is the first one. The second one will now be, and of course this is distance, it will now change to H. H equals UT minus half GT squared. Now the third one will now give us V squared is equal to U squared minus 2GH. Alright, so these three equations are the equations of motion to use when the object is thrown vertically upwards. Now we look at case 2. Case 2 is if the object is released. If the object is released from a height, above the ground. Now we have this equation will now change to V equals U plus GT. The second one will now change to H equals ut plus half gt squared. And the last one will now give us v squared is equal to u squared plus 2gh. Now the difference between this and this is just the positive sign and the negative sign. So the negative sign comes into play when the object is thrown vertically upwards. It is moving against gravity. We have minus here. Now when you now release it from a particular height, it has because it's moving in the same direction with gravity, we have the positive sign. Now I want us to look at the three cases where you use this: V, U, and H. Now the case one, the first point is if an object is released from a height, if it's released from, maybe it is, let's take the first one, projected from a height. If it's projected from a height, now at the maximum height there, the V there is 0. The initial velocity when it is projected will have it, but if at the highest value before it starts coming down, final velocity is Z. Now the second thing I want us to look at, assuming I reach it from a height here to 4, initial velocity at that time, U, is 0. Initial velocity before it strikes the ground is 0. So initial velocity is 0, while the final velocity before it strikes the ground is what you now have. You have the V. But the moment it strikes the ground, V becomes 0. So these are the two the two things I want us to take note of. Now the third thing I want us to take note is that time of flight. Assuming I throw this up, time taken for this object to get to the maximum height is equal to time taken for it to return to the same height from which it was projected. Now in other words, we have what we call time of ascent and time of descent. Time of ascent is time taken from where it is to the maximum height, while the time of descent is from the maximum height to when it returns or when it strikes the ground. Therefore, time of flight, capital T is 2 times small t. Small t is time of either ascent time or descent time. So in other words, if you are asked to calculate the time of flight is time taken for an object to move from where it was projected to the ground level where it drops. So these are the three things I want us to look at. Now, having done this, let us take 1 or 2 calculations. But before that, we'll clean our board. Remember our equation. I will drop this one here. So the first one gave us, we have plus or minus gt. That the second we have here h. Just want to represent it so that by the time we look at it, it will help us. We have this. While this other one is plus or minus 2gs. So we are going to be referring to these equations from time to time. Now we'll check the first question. The first question says, calculate the maximum height a ball of mass 1.2 kg will attain if projected vertically upwards with an initial velocity of 17 meters per second. So we have solution here. Let's say calculate the maximum height. So h is what we are looking for. A ball of mass m is 1.2 kg will attain if projected vertically upward with an initial velocity. Initial velocity u is equal to 17 meters per second. Okay. Now, given this, and of course, because the initial velocity is given like this. Now, the moment it attains that maximum height, v becomes 0. At maximum height, v is 0. Now, we have this, even though the mass is inconsequential here because we don't have anything to do with the mass. So, we drop the mass. Now, which of the equations will take care of, which of those equations will take care of v, h, and u? Remember, the question says maximum height, the body was projected upwards. So if it is upwards, you now have that acceleration becomes negative there. Now, the only equation that will take care of u, h, and v is this second one, of course, because it's, g is minus, we'll take this one. So which will now give us v squared is equal to u squared minus 2gh. And v squared, because v squared is 0, 0 squared is equal to u squared is 17 squared minus 2 times g. Of course, please, g is 10 meters per second squared. So we have times 10 times h is what we're looking for. Now, we now introduce by calculator, we have 0 is equal to 17 squared will give us 289 minus 2 times 10 times h will give us, of course, if we send this one here, we have minus 289 is equal to minus 2 times 10, 20h. Now, and of course, we'll make here the subject. H is equal to, this one will take care of, the negative signs will take care of each other. When I have h is equal to 289 over 20. Now, 20 divide this by a calculator will now give us 14.45 meters. So that is the maximum height the object can attain. I will take the next question, but before that, we'll clean the board. Now the next question says, an object falls freely from a height of 25 meters onto the roof of a building 5 meters high. Calculate the velocity with which the object strikes the roof. We have the another falls freely, and of course g is given to be 10 meters per second squared. It falls from a height. Remember, if this is the height, this is the height, let's say the height of a building. Now there's another building here. There's another building here. Let's say this is a roof of a particular building, where we have, let's say, this is the building, this is this. Okay, now we have that the entire height is here is 25, while the height of this building, where the ball is falling, here is 5 meters. Now, if from here to here is 25, from here to here is 5. From here, let's say from here now, from what will this place be? So if from here to here is 25, and let's say this is the roof. Let's use this as our roof. Now, the roof is 5 meters. From here to here, here will now give us 25 minus 5 will give us 20 meters. Therefore, the height of the building, where the thing is falling from, is 25. Is 20 meters because it did not fall to the ground. Because it did not fall to the ground, it is 20 meters. Okay, having gotten our height to be 20 meters, now we have the velocity with which it strikes the roof is what we are looking for. Now we have the equation that will take care of course, since it's released from a height, u is 0. Now the first question we'll ask ourselves is which of these equations will satisfy h, v, u, and g? And of course is released from a height, not against gravity. Because of that, plus of this, the positive of this will go. We now have v squared is equal to u squared plus 2gh. Now which will give us v, what we are looking for, is equal to, this is 0 plus 2 times g is 10 times h. V squared is equal to 2 times g is h is 20, okay? 2 times 10 is 200. 200 times 20 will give us 400. 200 times 20 will give us 400. So v squared is this. Now because of this, we'll take the square root of both sides. If we take the square root of both sides, this one will go, and we now have v is square root of 400. And if we take the square root of 400, square root of 400 will give us 20 meters per second. So 20 meters per second is the speed with which the object hits the roof of this. Remember, it did not fall to the ground. So was it to be moved from this place to the ground, then we would have used 25 meters. Okay. We now take a third question. Now we have this question that says, a stone is released from a height of 80 meters above the ground. Calculate its velocity just before it strikes the ground. Calculate its velocity just before it strikes the ground. Remember, released from a height. So when it's released from a height, it's moving in the same direction with the gravity. Therefore, g should be positive. Now we have a solution. When a stone is released from a height, the height is 80 meters above the ground. If it is just released, u is 0. Now v is what we are looking for just before it strikes the ground. Just before it strikes the ground. Once it strikes the ground, v becomes 0. But before it strikes the ground, and we have g to be 10 meters per second squared, and there is nothing given to us. So we have this, we have this, we have this. We check. Because there is h here, we'll still make use of this equation. V squared is equal to u squared plus 2, because g is positive, plus 2gh. V squared, see what we're looking for? This one is 0 plus 2 times 10 times 80. We'll now have 2 times 10, 20 times 80. 2 times 8, 16. So we'll now have 2 times 10 times 80 will give us v squared is 1,600. Now v is square root of 1,600, and it will now give us, the square root of 1,600 will give us 40 meters per second. Okay, the last but not the least question. This question says, a stone is projected vertically upwards with a speed of 30 meters per second from the top of a tower of height 50 meters. Neglecting air resistance, determine the maximum height it reached determine the maximum height it reached from the ground. Maximum height it reached from the ground, given that g is 10 meters per second. So if this were to be the platform from where the stone was projected from, now if you project it, it will go up and then return down. Now that means from here to here is that height given to us, which is height is 50 meters. Now this is the one that sorry. Now this is the height of the stone, the height attained by the stone. Of course, from here to here, we can have it as x. Now, so the maximum height from the ground is just from here to here. That is a maximum height. So we now take, let me use a capital H to represent it. So this is what we are looking for. The moment we get this, we'll add it to the height of the tower. Once we add it to the height of the tower, it will give us the entire height. Now, the surge is thrown vertically with speed, the speed with which it was thrown. Now, initially, of course, you know that at this maximum height here, v is 0 here. Therefore, the speed given to us is our initial speed with which the object was moving. So is 30 meters per second. Now this height here, from height of the tower, is 50 meters. 50 meters. G is 10 meters per second squared. Remember, it was moved up. Because it was projected up, the G will experience negative. It will experience negative acceleration. So we now have v squared is equal to u squared minus 2gh. Now this h, because we can do a little bit of alteration here. We can represent here with x. So that the moment we get our x, we'll add it to this. So maximum height will now give us h plus x here. So we now have v squared is 0, which is equal to u. U squared is 30 squared minus 2 times 10 times x, which will now give us 0 is equal to 30 squared is 900 minus 2 times 10, 20 times x, 20x. Now we can move this one this side, or we move this. So whichever way. If we move this one now, we now have minus 900 is equal to minus 20x. Now we multiply both sides by minus 1 so that these negative signs will go. And if it goes, we now have x is equal to 900 over 20. And of course, 90 divided by 2 will give us 45 meters. Now, from the height of the tower to the maximum height the stone got to is x, and the x is 45. Therefore, maximum height from ground is now x plus h, which will give us 45 plus 90. Sorry, 45 plus 50, and it will give us 95 meters. So from here to here, this is 45. 45 plus this will give us 90 meters. Okay. This is where we draw the lesson to an end. Please, If you have not subscribed to this channel, do well to subscribe to this channel so that subsequent videos, you will get subsequent videos. If this lesson was helpful to you, please give it a thumbs up. Like this page and then follow me on social media so that the moment I drop new videos, you will get notification. Thank you. We'll see you in the next video.